Hello everyone, we will learn a new element today, operational amplifiers, op-amp for short. The op-amp is different from the resistor, the inductor, the capacitor. It is a multi-terminal element, also an active and integrated device. As its name implies, it has two functions, operation and amplification. Operation means addition, subtraction, multiplication, division, power, square root, logarithm, and exponent, differentiation, and integration. Op-amp was invented in 1930s, and it has become one of the basic parts of the analog computers in 1940s and 1950s. Its integration capability and reliability improved year by year since 1960s. These are some common op-amp encapsulation forms currently in the market. This is a DIP package, this is a SOP package, and this is a TOP package. This is an integrated chip of op-amp with a DIP package. You can see it integrates 4 op-amps. They use the same source and ground, which shows a high integration. In fact, op-amp's internal circuit is very complicated. This is a typical internal circuit of the op-amp. There are many transistors, resistors, and capacitors. In our course, you don't need to know how its internal circuit works. We only require you to know its external characteristics. That is, characteristics seen from the terminals of the op-amp. The terminals are inverting input terminal, the non-inverting input terminal, the power supply terminals, and the output terminal. It can be seen that this op-amp is powered by 2 power supplies, a positive power supply and a negative power supply. In fact, many other op-amps is powered by 1 power supply. The op-amp is represented by this circuit symbol in our circuit analysis. Corresponding to the real op-amp's terminals, the circuit symbol has the inverting input terminal A, the non-inverting input terminal B, the output terminal O, the power supply terminals VCC, and the ground terminal. We can also see this triangle in the circuit symbol. It means the signal flow is one way inside the op-amp. It can only flows from the input to the output and cannot flow reversely. Capital A is the open loop voltage gain. Usually, its value is very large, whose order of magnitude is about 10 to the 5th or to 10 to the 8th. For simplicity, the circuit symbol can be simplified further like this. Its ground and power supply terminals can also be omitted. Let's think about whether its inverting input terminal, non-inverting input terminal, and output terminal can be seen as a generalized node to apply KCL. The conclusion is obviously not. Because in the simplified circuit symbol, the power supply and the ground terminals are omitted. You cannot be sure that the algebraic sum of the 3 terminals currents at any time equals 0. Well, then we take the 741 op-amp in multisim, for example, to see how to connect the op-amp and set some typical values of the key parameters in multisim or other simulation software. This is the user interface of Multisim 12. There are 2 ways to place a circuit model of the op-amp in Multisim. One way is to choose component in place, then choose op-amp on the left. Many op-amps models are listed on the right and can be chosen according to your requirement. The other way is quite simple. Click Place Analog in the toolbar, then you will see op-amp here. Let's take 741 for example to introduce some typical parameters of the op-amp. It's a 7-terminal circuit model, which means it has 7 terminals connected to the external circuit. You've known 3 of them. The first is the non-inverting input terminal, the second is the inverting input terminal, and the third is the output terminal. What's the other 4 footprint pins? We can see its circuit model parameters by double-clicking it. Let's look at edit footprint, which means to see its footprint. The non-inverting input terminal is footprint 3. The inverting input terminal is footprint 2. The footprint pin 4 is a S-, which represents a negative power supply. The footprint pin 7 provides a positive power supply. The footprint pin 6 is output. The footprint pin 1 and 5 are used for balancing in the op-amp. We usually leave them open without connecting to any part of the circuit. If we want to make this op-amp work properly in the circuit, footprint 4 and 7 should be connected to the correct power supply. We've seen previously footprint pin 4 is connected to the negative power supply and footprint pin 7 is connected to the positive power supply. What's the voltage of the power supply? We can also see its parameters. Now we need to click Edit Model to see some parameters. You can see a lot of parameters of the op-amp. In fact, we are only concerned about the above ones. Let's analyze them one by one. VCC is 15, which means its positive power supply is 15 volts, and the negative power supply is minus 15 volts. There are 2 power supplies. Capital A is 200,000. It's the open loop voltage gain of the op-amp. Ri is the input resistance of the op-amp. The given typical value is 2 mega ohms. Ro is the output resistance of the op-amp. The given typical value is 75 ohms. Let's see the following line. VSW positive is 14, while VSW negative is minus 14. VSW is short for voltage swing. It means that this is the saturation voltage of the op-amp. The saturation output voltage of the 741 op-amp is positive and negative 14, which is a little lower than its power supply's voltage, positive and negative 15. These are the key parameters we should be concerned about when we use or buy op-amps. In fact, there are some other parameters like CMRR, which is its common mode rejection ratio, and other parameters. You don't need to know them temporarily, and we'll learn about them in the following analog electronic circuits courses. You should pay attention to this parameter. SR is 0.5. SR is short for slew rate. Its unit is volt per microsecond, which is the maximum variance of the voltage per microsecond. In fact, the parameter represents how fast the output of the op-amp can follow the input of the op-amp. Thus, the op-amp is often applied in DC or low-frequency AC circuits. We should choose specific high-frequency op-amp if applying it in high-frequency circuit. Otherwise, the output may have distortions or even the output is totally incorrect. Well, now we connect the correct power sources to the 741 op-amp. We've known the 2 power supplies is positive and negative 15. So we place a DC power here and place another one here and place a ground here. Okay, we know the footprint pin 4 should be connected to the negative power supply. So flip it vertically and change the voltage to 15 volts. The footprint pin should be connected to positive power supply 15. So flip it vertically too, then connect them Okay, this is the correct connection for the op-amp power supplies. The external circuit will be connected as it shown in real circuit. The footprint pins 1 and 5 are usually opened. Please note that you cannot connect the negative terminal of this source directly to the positive terminal of this source without the ground connection in the middle, because in that way, it only means the voltage between pin 7 and pin 4 is 30 volts. You cannot guarantee pin 7 is connected to a positive 15 volts and pin 4 is connected to negative 15 volts. You should pay attention to this in the simulation.